the measures you can take in order to improve the performance of your plant. And this is one of the, what we call the residual lifetime assessment. Reason for this is, as you can see here on the graph, there's a huge, and you all know of this, you are part of it, there's a huge amount of lifetime extension and R&M measures in the 12th plan. We're talking about 135 units, almost 30 gigawatt worth of load, plus some leftover from the 11th plans. So there's a huge amount which comes along our way. So the question we've been facing together with our customers, with you, are often, so what are the measures which are required to have a reliable and available thermal power plant operation? And then the question always comes between, should it be an LE, lifetime extension measure only, or an R&M? What efficiency improvement measures should be conducted, and what is the right solution to get the optimized return of investment? We think that it has not to be one or the other, it could be a combination, but in order to come to this, and actually to answer this question, what should be done, from our point of view, is you should do a residual lifetime assessment. This can help finding the answer to you. As already explained by a lot of my colleagues which were before me, that's another advantage of being the last, not only being between you and your beer, but also that a lot of this has already been said. The aging of the turbine comes from a lot of stresses which come from startup and shutdown, the thermal stresses, creep damages, but also the low cycle fatigue due to the startup and shutdowns, vibrations, you have a lot of erosion, corrosion, some particles maybe being in the system. So a lot of these lead to these fatigues, which at the end of the day will lead to some requirements in maintenance programs. Oops, that was one too much. So, and as you can see here, over the time then the failure probability due to the aging, due to the fatigues increases. So, and at the end of the day, if you would not do anything, we all know this could have any failures, and in worst case, even have catastrophic failures. We all want to avoid this. I mean, to be in the press might be something nice, but in this case, you don't want to be in the press. So that's why we all are here, and we are continuously doing inspection methods. And of course, as wise people, we all take corrective action if incidents show some issues. So we have developed a plan, a program for this within Siemens, which says that you, and you all probably follow most of this, during the lifetime of your product, you do continuously non-destructive examination, inspections, and in order to understand exactly by the end of your product lifetime, your design lifetime, what the status of your turbine is. Latest by the technical design time, after 200,000 operating hours, you would want to do this inspection and then identify what measures are required. There's a little process in this to come to the results of this lifetime assessment study, which is first you do the NDT test, then you do the evaluation of your operational hours, the historic ones, as well as a future regime. And then you can do the remaining lifetime analysis, which brings you then the result on which basis you can make sound decision of what lifetime extension measures you would need to take in order to get the best bang for the buck. We used to say the most return of investment. This could mean that you have to say, I'm just restricting my operational mode, and maybe I just use my turbine as a peaker, or I only have reduced operation, reduce the power output, or I would repair or replace components. And on some other occasion, as we have heard, also the modernization, meaning the upgradation, efficiency improvement could be a solution for this. But only you can decide what is the most economically for you. And this is based on a very detailed and fundamental investigation you have to conduct up front. And then I think you will get the best for your money. And then the process restarts again. You have an extended lifetime, and you continue to do your measurements and your outages. Some of the NDT measures, as already also explained, to only name a few, there are magnetical particle tests, for example, ultrasonic phase array inspection, microstructural investigations, as you can see here, for example, will lead to the information you need to know about your components. Here's an example of a blade root ultrasonic inspection. As you can see here, the probe will be put directly on the blade. Here, those gentlemen are conducting this right in the field, and they measure exactly the root here. And as you can see here, there are some indications, some cracks have developed over the time in this root. And if you would not do anything, as you can see here in this picture, these cracks prolong a lot more. And as you can see, if you don't do anything, the likelihood that those give away and your blade will surface, meaning going out of your turbine, is pretty high. So you have to do something in order to make sure that you have safe operation. Now, what kind of measures you will be taking, whether you just do a one-to-one replacement or do a little modification of the root and have a better stress distribution in the material, or if you go for a complete modernization, that of course is then in your decision based on the facts we will provide, based on the performance improvement we can provide on the entire turbine, and of course of your expectation in the operation mode, your expectation in how long you will operate this machine, and all these considerations only you can put into the account. One other example is, as we want to have also ultrasonic inspection of the entire rotor, typically what you have to do is you have to pull the seal strips. We have developed in our R&D program a method where we apply a water, basically equipment which comes to the rotor, and with this it's kind of like the Gale on your doctor when you go there and you have the ultrasonics. You know, he puts a Gale on it and have a better measurement. Here it's the same. We do this with water, and with this water we are allowed not to take the seal strip out, which will reduce your outage time. So you have very good or identical information on the ultrasonic test as if you would pull the seal strips, but you don't have to do it, which reduces the time and gives you much benefit in reducing the outage time. And I think one of our colleagues has shown how much money that could be.